Hi and welcome to the 6-1 homework help video. This is the first homework for Unit 6 and it deals a lot with balancing addition and subtraction problems. Now I'm starting on our homework that is due this upcoming Tuesday. I wanted to go over maybe how to do one or two of these problems so that in case you get stuck at home you might be able to follow and come along with me. We're going to start with number 1. 2 professional baseball teams played a 4-game series. Attendance for the first 3 games was 126,503 people. What was the game 4 attendance if 107,318 people altogether attended the series? So, one of the first ways we can handle this and deal with this is called math mountains. Math mountains are also called break-apart diagrams. But I like to use the mountain because it ends up looking like a mountain. Now, using a word problem like this one, I need to really identify the numbers that I know and the numbers I don't know. Alright. In this 4-game series, if 1,000... Oh my gosh, I have a hard time with this number. 171,318 people altogether attended the series. That needs to be the number that goes at my top. Because it tells me when it says all together. The other number I know is the attendance for the first 3 games, which is 126,503. What I don't know, my unknown amount, is my variable. I'm going to use G for game as my variable. The instructions on this ask you to write an equation and use it to solve. Draw a model if you need to. This is probably your best kind of model. But now I can turn this model into 2 kinds of equations. The first kind of equation is called a situational equation. A situational equation is the one that comes and reads just as it does in the problem. So for example, in this one, I would start with attendance for the first 3 games was 126,503. We're looking to find game 4 attendance. And we know that if we added these together, they would equal 171,318. That is a situational equation and can be used to find our total. In order to find a total using this, we need to make sure to see if we can get this variable, G, all by itself. Because I'm trying to see what G equals. So I've got to get rid of this positive 126,503. So I'm going to subtract it. But anything I do on one side of an equation, I always have to do on the opposite side of an equation. I have to do this because I need to make sure that both sides are equal. So I'll go ahead and now I'll subtract 126,503 from this side as well. This will actually give us our, what's called solution equation. A solution equation is written in such a way that the variable is by itself, like that, and we know what it's equal to. In this case, 171,318 minus 126,503. In this case, G equals, I'm actually going to let you guys do that math. You might have to do it on top of each other. So 171,318, 126,503. looks like G equals 44,815. All of these, so this model got us to the situational equation, which then got us to our solution equation. All of these are applicable to answer any one of these word problems that are due on Tuesday. Let's go ahead and do another one, maybe one dealing with fractions. We talked earlier today about the fact that fractions and decimals aren't going anywhere, and we're going to have to use them, even in situation and solution equations. Let's go ahead and talk about number 4. Number 4 reads, the heights of horses are often measured in units called hands. Abigail's pony is 13 1/4 hands tall. How much taller is Germain's horse if it is 16 1/2 hands tall? I wanted to pick this one because the first thing is I wanted us to really think about just ignoring that first bit of sentence, aside from the real information it has. The heights of horses are often in units called hands. We really don't need to know that, as long as we remember that these are in hands, and that you're not really thinking about, well, do I have to measure my hand? You don't. We're just worried about the number and using hands as our unit. Let's start with doing a math mountain for this problem. My math mountain, I'm going to start by just drawing my mountain. In this case, I'm comparing two horses. That first horse is 13 1/4 hands tall. And I can put it right there. I'm putting Germain's horse at the top at 16 1/2 hands because it's going to ask me to find the difference between the two of them. I'm using H as my variable this time for hands or horses because I know that some measurement, some number of hands plus the height of Abigail's pony, which is 13 1/4 hands tall, is going to equal the same height as Germain's horse, which is 16 1/2 hands tall. So now I can go ahead and I can do my situational equation. In this case, I'm going to go ahead and use my math mountain again, and I'm going to start with the 13 1/4, adding H, my unknown number of hands, to find the difference. Okay? How much would I have to add to this to get to this? That's what my H is asking. This is my situational equation. Now I can take my situational equation and go right into a solution equation where I want to get H all by itself. Now, I need to make sure I can get rid of this 13 1/4. So I'm going to go ahead and subtract on both sides. Because we're dealing with fractions, you're going to notice right away that we have a problem. I have different kinds of units here, fourths and halves, so I've got to find a common denominator. Don't worry, don't panic. We can do this. Assuming Mrs. Beatty can find a marker. Alright. I will need to find a number that both 2 and 4 go into, which in this case is going to remain 4. So I can keep 1/4. But I know that if I change this to fourths, I had to multiply 2 times 2 to get to 4. I've got to do that to my top as well. So now I have 16 2/4 minus 13 1/4. That makes my life a little bit easier. 2/4 minus 1/4 leaves me with just 1/4. 16 minus 13 and gives me 3. So now I know that H, the number of hands difference between these two horses, is 3 1/4 hands. I can also write this as a solution equation. H equals the height of Jermaine's horse, which was 16 1/2, minus the height of Abigail's horse, which I know is shorter, so that we can find the difference. You'll still have to find a common denominator, but you will, in the end, get the same result. The difference between the two is 3 1/4 hands. Hope this helps. If you have any other questions on your homework, feel free to circle the question and make sure to ask Mrs. Beatty at the beginning of math so that you have a chance to solve it as a class. Thanks for watching. Have a great night.